So is this the parent function of an exponential function? Yes and no. Because this is also a parent function of exponential. It has a base, it has an exponent where the variable is, which is why it is an exponential function, right? Because the variable is in the exponent. There's nothing being added, subtracted, multiplied, or divide. It's just that these two have different bases, don't they? What about this one? Is this also a parent function? It is. Okay? So how many parent functions are there for the exponential function? Infinite. Because I didn't even do any fractions. I didn't even do any decimals, did I? Okay? So that's what's slightly different about exponential functions compared to the other families of functions that we've talked about before. Quadratics, the parent function was y equals x squared. And that was it, right? The base, the number here, the 2, the 3, and the 10, that's what gives it its initial shape. Okay? But again, there's nothing being added, subtracted, multiplied, or divided to it to change the value, to shift it around anywhere on the graph. So these are all parent functions. Now, you know all the rest of the answers that I'm about to ask you, of the questions I'm about to ask you. What happened if I say plus 5? How does that change compared to its parent? Vertical shift, up 5. What happens if there was a negative sign in front like that? You're good with those, right? What if it was minus 2 up inside the exponent? Close. It's inside. What kind of changes it if it's inside? Horizontal, right? And what kind of change is it? It's being added or subtracted, so it's a shift. Now remember, when it's inside, it's opposite of what we think. So minus 2 would be right 2. And what happens if this right here is a negative? Over what? The y-axis. What happens if right here, inside this exponent right here, it says 1/2? Can you even see that? Is that better? What is that? That's a multiplier, and it's inside, so we know it's a horizontal change, right? It's either a stretch or compression. When it's inside, it's opposite of what we think, right? So we see that it's between 0 and 1, and we automatically think it's a compression, but it's a stretch. By what factor? Why is it 2? Because 2 is the reciprocal. Yeah. Okay, reciprocal. What happens if out in front is a 3? So it's 3 times 10. Let me rewrite it so you understand what I'm saying. 3 times 10 to the 1/2 x. We already know that the 1/2 x causes a horizontal stretch, but what happens with the 3? It's a multiplier, so we know it's a stretch or compression. It's outside, so we know it is vertical. Because it's outside and it's above 1, What is it? It is a stretch. By what factor? Any questions about that? Okay, we need to talk about something new that we've never talked about before. What about if this was the equation I give you? I know your whole life you've been told that E is a letter. That's because it is. Okay? But in Algebra 2, we use the number E. Okay? Just as a little side note, the number E, I think I can actually use the equal signs here, but we'll leave it that right now. 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial dot dot dot. And that's why I think I can put the equal sign, because I put the dot dot dot. Now, just to be clear, this does not say 1 over 2. That says 1 over 2 factorial. Do you remember what a factorial is? Have you ever talked about a factorial before? Okay, for instance, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. What's 4 factorial? 4 times 3 times 2 times 1. What's 3 factorial? 3 times 2 times 1. What's 17 factorial? I'm just teasing. We don't have to write that out. You know what it is though, right? 17, 16, all the way down to 1, right? Okay? That's called a factorial. Now, there was a guy, he's dead now, okay? There was a guy named Leonard Euler. Leonard Euler, who discovered this number. Okay? One of the Bernoulli brothers, either Jacob or Daniel, I think. I don't remember which one it was. I'm sorry. I can look it up if you really want to know. Or you could. Really looked into this a lot, really studied a lot, and figured out a whole lot more stuff than either Mr. Euler did. But when he was working with the number, when Mr. Bernoulli was working with the number, he actually called it E in honor of Mr. Euler. Because Euler starts with an E. Yeah? Okay? This number is really quite important. Okay? We, in Algebra 2, start using it when we talk about exponential functions, because it's going to show up when we're talking about applications of exponential functions like compound interest. We're not there yet, so I know we haven't talked about that yet. We've talked a little bit about simple interest. We're going to start talking about compound interest. You're going to see the number E show up. When we get to logarithms next chapter, it's going to show up a whole lot more. Okay? And then the further up you go in mathematics, not every single upper level mathematics class, but a lot of upper level mathematics classes use the number E a lot. It's a pretty important number. Okay? I don't know that you've ever seen it before. I don't know that you talked about it in Algebra 1 at all. I'm pretty sure you didn't talk about it in geometry, but in Algebra 2 we really start to look at it. So I wanted you to know who started it, where it came from, what it means, and then we can start using it, and I'll show you how it's applied. Okay? The cool part about it, though, is all of these transformation rules that you already learned still work for this. What if I put a 3 out in the front of it as a multiplier? What's that? Vertical stretch by a factor of 3. What if I put a negative out in the front of it? A negative? It's reflecting over the x-axis, right? What if I put a -2 up here inside the exponent? It's the same thing when I put a -2 right here when our base is 3. Okay? All the same rules still apply because E, this E, is a number. Does that make sense to everyone? Okay? Do you have any questions? Someone asked me a question that they either don't know or think other people might have a question about. Somebody asked me a question. Is there any transformation rules that it can't be used for? No, and that's a good question. We good? Why the exclamation points? Exclamation points are a factorial. That's just something that's also another part of math. I'm not sure if you guys have seen yet. You might have seen it when you did probability and stuff like that in 8th grade, but I'm not sure. Okay? Any questions about this? The main thing that we're going to be using the number e for, or in general? The number e, the main thing we're in Algebra 2 going to use it for is this chapter and next chapter, exponentials and logarithms. And I don't want to spoil anything by talking about the application data. I did talk a little bit about compound interest. When we talk about compound interest, e is going to show up a lot, but there's a lot more exciting stuff that I'll leave as foreshadowing. Okay? Something for you to look forward to. Something else for you to look forward to in this class. How about that? Okay? Any questions?